Hello, welcome. I'm Bill Wake. We're here working on an Elm interpreter. We've been at it for a number of sessions now, and we're working on sequences of expressions that basically boil down to function calls. So let's see where we are. And we definitely stumbled around on this a few days ago, but I think I'm ready to tackle it now. Okay, so what we did, well, lately, let's see, we got our to do. So yesterday we worked on the EQ function. We introduced this multiple expressions class, and I'm not sure if that's a good idea or not, but um, we know the issue we have is when you make a definition, you do like function of xy equals some expression, and you also could call function xy, and until you see the equal sign, which could be arbitrarily long from the start of the line, we don't know which one we're dealing with, a declaration, a new function definition, or a function call. And so this multiple expression class is designed to hold on to things until we know what we're doing. And so we got the definitions working, turning function definitions into lambda expressions, and improved some printing. So I think that was good. And then what I'd like to do next is function calls. Originally, I thought I would be doing the variable followed by arguments, but I think a lambda expression is actually an easier deal. Um, and maybe it's, yeah, I think we'll start there. All right. So the parser, here's, let's see, let's start at the top, the definitions. Okay. So a function call definition is expressions like fn xy followed by an optional equals expressions, which is the right hand side of a definition. If you don't have the right hand side, you just have expressions to evaluate. So we call expressions to find them all. We do some error checking, and then if we have equals, we pursue a function definition. Otherwise, we figure out if this is a one expression deal or a multiple expression deal. And I I don't know. That almost seems like it's okay as is. um, and here's the equals. Plus, you had var plus equals expression. We make sure everything's a variable, and go on and parse the expression. And down here is where we handle the multiple expressions like fn of xy when it's a function call. And we get back this multiple expressions. Well, I think it's have treated multiple expressions as kind of a temporary structure. It's a holding structure while we decide what to do, and at the point where we know it's this, we have a function call. Okay. Well, that kind of sounds like it should work to me. The only thing going on different, I think we could. Well, this expression, maybe we don't need lowercase name whatevers. I think at some point I want to introduce the notion of a factor, and a factor could be a function call or maybe it's a parenthesized expression. Maybe it is this series of expressions. I don't know. All right, let's run this thing then. I mean, it looks kind of like it might do something. High praise, I know. Okay, so let's try a lambda x goes to x. Very simple definition, and we get a function back. Whatever type goes to whatever type. A is arbitrary at this point. All right, now let's evaluate that. X applied to 3. Okay, so we have a series of expressions, first of which is a function, and we evaluate. It should evaluate. Wow. I mean, that's a pretty limited lambda, but We could also do lambda x. If true, then x else 7. Okay. And notice this thing is a float, so it's going to force our number to a float. Let's evaluate. 3 a float. Okay. I guess I should be happy it works. We did do some work on function calls, so it's not like we didn't try and make it go, but I think this is a case where getting the stuff in place just kind of does the right thing. So I got to figure out now. I think we have stuff that doesn't realize that or something. Okay, so let's take this top level one. You parse the expressions. You look for any errors. You parse the definition if it has one. And then if there's only one expression, you just return it. So if the expression was 3.0, we just return 3.0. Otherwise, we assume it's a function call. And we're going to evaluate it with the inner expressions from the original expressions. That's all right. Okay, so here's expressions. It just finds all the expressions, builds this multiple expressions. Okay, the one expression. Now this, I think we don't need, we put this in saying, oh, we're going to have to get the expressions, but it looks like we're okay. Lambda expression will just get it. I'm sorry, lowercase name will just be itself. Lambda expression will be itself. And alternatively, an if statement. Okay. Parenthesized expression, a little bit of a yeah, because we had tuples, it becomes a little bit of a mess. Oh goodness, why do you have to use the same syntax for tuples and expressions? Now I don't know if this will work. We could make a function function of x equals, if false, then 3 else x. Legitimate function definition. I don't know what we're doing with it. Are we sticking it in the dictionary somewhere or something to have it? I don't know. But I theoretically could call function of 5. And let's see what happens. I get the number. Okay. I mean, I should develop a better poker face because I'm just kind of surprised. I thought we had some work to do here. All right. So, given that these things apparently work, or at least somewhat work, or something, then I think we're in kind of good shape. Oh, let's see. We don't need this junk. I don't know what that was. Okay. And we don't handle operators yet, but let's work on the look of this. Now, one thing I know, this multiple expressions thing is kind of a pain. And maybe I think maybe we're working too hard for it. So we got this multiple expressions and we return that. I would like to explore just returning the expressions, but see, it switches its mind. Okay, and when it finishes parsing the list of expressions, it checks if any of them are errors and then returns error. It's like we're wrapping it up so we can have the same return type, but instead I want to pull this code up. Okay, and really I could like inline and re-extract or something, but I'm just gonna say, after I get back, whatever I get back, I'm gonna look at it and decide. Okay, so let's see where it's called. We saw there was only one place up here. Okay, and the reason I'm doing it is because I have this going on. All right, and not only do I have to check it down there, I have to check it up here again. So that seems redundant to me. So let's, okay, so in this case, we want to look at, I'm going to move this up. Okay. And I'm only going to return the errors. The multiple expressions. Okay, so rather than checking before I put them in the multiple expressions, I'm going to get the multiple expressions back and then check them. Okay, so I have LHS dot enter expressions dot first, where it's an error. Okay, if any of those is an error, return it. Okay, and so I don't need this. It's checking the same thing. All right, so let's run tests. No failures. Okay, good. All right, now I'll clean out down there. Okay, and I get these multiple expressions. I look for anything that is an error. Then if I see this, and then I do this down here. Okay, so the change I want to make, let's commit this. Move error checking from expressions to function call or defs. Okay. All right, so that has simplified expressions, but now I don't even see the benefit of multiple expressions here. I could just return an array of expression, and I'd be happy. Let's just return the expressions. Okay, and I'll keep this line and delete this line. Okay, so basically run through, grab all the expressions you can, and return the list of expressions. Now that should upset this. Okay. Expers is really array of expressions. Okay, so I could wrap it here. Well, okay, I guess I could change the name here. Let's call it results for now. Let's call this expers. And this is wrapping results. I don't know. We'll fix the naming shortly. Okay, but now this LHS equals expers as multi-expressions. It is multi-expressions. Okay, so let's test. Okay, now I want to work with these expressions. Everywhere I'm using expers or LHS, I want to work with results instead. Okay, so LHS.enter expressions is results, so I'll just use results. LHS.enter expressions is results. Okay. Now, let's see, where's LHS? I missed one. Results. Whoops. Wrong keystroke. All right, let's run tests. Okay, now nobody's using LHS and nobody's using expers. Okay, so I got rid of multiple expressions completely. Let's call this LHS, left-hand side. Okay, much smaller. All right, so now if anybody has an error, then we return it. We look for the equals definition, and then I'm going to see if I can put this on one line. I think it'll scan okay to us, the reader. Okay, so if the line LHS count is 1, return it. Otherwise, return a function call wrapped around it. That seems accurate. Now, okay. Run this. Okay, I'm going to clean out this comment stuff a little bit. That was kind of helping us understand it while we were, at least while I was stumbling around. Okay, function call or definition. Get expressions. If there's an error, return it. Otherwise, return function definition. And if it's not a function definition, it's a call, so get the values. Okay. That's a nicer method, a lot nicer method now. Okay. And this one is a lot nicer method now. So I would say we've improved both noticeably by giving this thing not needing the extra type. So now multiple expressions. Oh, I regret your loss, but I think you're going. Is anybody referencing it other than tests? Well, it's kind of hard to tell. Let's search for this. To do this, and it's tests. Okay, so this is dead code. I hope it made us smarter, because otherwise it was just a waste. And where's multi-expressions test? Oh, in my off time, I alphabetize these folders. I just hit my limit. And I don't know, it's like I could make a case like I would expect that this is a symptom of too many things there, but I feel like they're all kind of legit. They all come together as children of this, the main interpreter node expression, and they belong in that sense. I don't know. We'll see. All right, let's test. Okay, so I can commit this, delete dead code, multiple expressions. Oh, well, we probably cleaned up other stuff in there too, but that's okay. All right. So where does that leave us to-do wise? Lambda followed by arguments? This... Okay, I think we've made progress on function call. Story function call. We checked both these. They seemed okay. I'm not 100% sure the lambdas and the closure and all that stuff is straightened out. But I do think we can handle this situation. So a function should know how many expressions should follow it. All right, so the case we're looking at, Elm-Ripple, let's say we function of x, y equals x plus y. All right. If I call function 2, 3, 4, it should complain. Yep. Because it knows function expects 2 arguments and got 3. Now, the reason it knows it is it's got a lambda, which points to a lambda, which returns something. So there's some counting going on there. Um, if we do the same thing, lambda x goes to x 1 2. Okay. The message could actually use some work. Lambda x goes to x calling 1 should be okay. Yeah, so it's saying, well, you could have done this. Lambda y goes to y times 2 to 2. And we would plug in x as the function and then evaluate it with 2 and get 4. But I think the real issue is we had an extra argument to this one. But okay. And maybe it's okay when you interpret it something, I don't know. Let's develop a case. Let's try the equivalent of that first line. Lambda x goes to lambda y goes to x plus y applied to 2, 3. Yep. And then same thing. Can I up arrow? Yeah. 3, 4 should complain. Okay. So it knows when it calls. Yeah, this is an interesting thing. So it knows when it calls this. It knows it's got a 2-argument function. That's fine. This case we had here, that's kind of interesting. Because it can't know this until runtime when I plug in this function and then this argument, then it's okay. So I think the function call, well, it's kind of mysterious to me now. I go through life like this. All right. So I've got function 234. That's a problem because function takes 2 arguments. But it knows their numbers, so it can't do any fancy stuff. That's the difference here. This thing doesn't commit you to a type, and so the type could be function. And so it evaluates this. My feeling is it evaluates this with 1, gets a 1, and realizes, like, I can't call 1 of 2. That's just wrong. 1, 2. All right, let's see what we do over here. So if I say 1, 2, something should be unhappy. Something's very unhappy. Wow. Okay, what's going on? Oh, okay, so our error handling's a little wimpy there. Yikes. This is function call. Okay, let's stop here. Okay, so function call, if you evaluate it, it's going to take expression sub 0, evaluate as a closure, to do. Yeah. Okay, so maybe this is where we need to pick up. If you call this, you should get a function back. Now, it should be a closure. It can't be an integer value. Yes, that's completely clear. Well, I think we have closure and we have lambdas. I'm not sure if we consist. When do we wrap our lambda into a closure? But if it doesn't, um, well, if let's assume you're supposed to be in closures. If you don't have a closure at this point, this evaluation is wrong. So evaluating one as a function can't be good. And then once you have it, you apply the function to the expressions with the context. And then somewhere we said, oh, how about an error message? Okay. Let's work on a test case for this one. So if you evaluate 1, 2, that should be some sort of error. Okay. Okay, we'll take a function call. All right. What's in there? Well, there's a lambda. No, we're going to make an integer value 2. Integer 3. Okay. And maybe I can fit this on one line. Turn off that view. Okay. Not bad. Okay, so I want to assert if you evaluate this with an empty symbol table, you should get an error expression of some sort. What do we call those? Error messages. I don't know. There's probably better messages to write, but we'll get something in there. Okay. So if you try and call 2 of 3, I'll just assume it's nil for now. Error messages has no member function call must have function. Okay, so let's build. All right, if you call 2 of 3 as if it were a function, we expect to get an error message back that says function call must have a function. Okay. And we're pretty sure that will fail. Right. Okay. So function equals expressions dot evaluate. Let's break this down. If I guess we can do this as an if let. Function equals evaluate context as closure. I want a guard. I gotta look that thing up again. Well, I'm not doing it. Okay. Guard something else error. Okay. Let's let the function equal that. Guard function is closure else do something, and then just do a thing. And this is what we're doing. Error messages dot function call function call must have function. Okay. Well, let's do it this way. As closure. All right, I'm going to try and turn it around again. Let's do this. If let that if the thing is a closure, then we're going to do this. Otherwise, we're doing this. Okay, evaluate that function as, evaluate the first argument. If it's a closure, then apply. Otherwise, it's some sort of error message. All right, we'll test. Nice. Okay, good. Okay. Make function call enforce that first expression is a function. Okay. Now, so when we run 2, 3, we should get our error message. A non-function cannot be called. Okay. I don't remember what this tag is. Oh, that may be our location. Now, do we have... We don't really have a location at this point. That's too bad. Yeah. All right, but we have finished what we set out to do, which was enforce. Well, I guess we enforced function call must have a function first. Okay. Now the number of arguments is a interesting thing. I mean, I'm going back to the REPL. Like this case we had lambda x112. What's weird there, and maybe even more this one at the end of the line here, or end of the page, it expects... There's no way to know it was wanting a function. Until you evaluate it. So it had to do lambda x goes to x, call that with 1, and then see, is this result a function? If it is, I can pick up the next expression. And that is, that's... I'm not sure how that's going to work. Lambda x goes to x. Let's try one. So if we do lambda x goes to x, call it with lambda x goes to lambda y goes to y, and apply that to 1, we expect 1 to come back, because it calls the first lambda calls itself with the second lambda as the argument. The result of that calls itself with the 1 as the argument. I don't know. Should not happen. Okay. There's something going on. Oh, I can't cross domains. Okay, let's try this again. Lambda x goes to x, called with lambda y goes to y, called with 3. Should be 3. Okay. So we're not doing something right. And I'm not clear if it's... Yeah, I'm not clear where that's coming from, because when we parse, we get the whole list of expressions. I guess the thing is, you have to evaluate to know, because that lambda function the second lambda function could have been anything. Okay, so when you call, let's see, when you make a function call like this, I think it's going to take that first function and it's going to ask, how many arguments do you have? I don't even think it's doing that. It takes the first function, passes in the first argument, and does whatever that does. And then when it gets the result back, if it has more expressions following it, it should get them. So an expression... Lambda x goes to lambda y goes to x plus y. You can call it with 1 argument. You can call it with 0. You just have a function. 1, you get a partially evaluated function. Or 2, and it evaluates the whole thing. If you call it with 3, I think it needs to call it with as many as it can, but no more. And If it's got extras, it needs to hold those in reserve. Now, I don't know if Elm has a var_args kind of thing. Let's ask that question. But I think what I'm coming to is you need to do it. You need to evaluate the function, see if there's any more parameters, and keep evaluating it while you have parameters. Variable arguments are used in the printf family. That's C language. Okay. Elm var_args related compiler failure. Elm does not compile with GCC. That sounds internal. All right. I'm not seeing anything that makes me think there's anything like that. I mean, it's so easy to create arrays that you would think you could just slap it in an array and you wouldn't, you'd make a list out of it or something. That wouldn't be too hard. Okay. So I've got my working theory now is the function call needs to be more sophisticated. It's got the list of expressions. It should say how many arguments do you want expression 0, and that comes back and says I need X arguments, and expressions supplies 0 to X. Okay, it's a good time for a break. I'm melting my brain here. All right, so we'll take 2 minutes and we'll come back and see if we can make our evaluation a little more sophisticated. Welcome back. All right, so we left off trying to figure out this evaluation, and I think maybe it's even simpler than I'm making it. Maybe what you do is if you're a function and you must take at least one argument. If you don't have an argument, then we just return you. There's no applying. Okay. If you have an argument, we call you with the first value. Uh-oh. Let's see. See if I can wake it up. Thanks for the heads up. All right. Let's see. So if you have a value, we can peel off the first argument if it exists. If it doesn't exist, we should just return. We shouldn't even evaluate. And if it does, we give it the one argument. It evaluates. This is the currying thing. It can, if it has multiple arguments, it returns a function of the remaining arguments, and then we're going to repeat the process. Okay, how to make that go? So, if you take expression 0, and it only has the one. I mean, there's only one thing in the expressions list. Then it should just return that. I think. Okay. So the corresponding case for that would be something like I got 3 left parens, lambda x goes to x, right parens. That returns a function all the way up, and I should get a function type out of it. Okay, that seems good. If I did the same thing, x, and call it with 3, it should evaluate all the way up and then say, oh, I got a 3. Yeah. Okay. So I think evaluate needs to be more sophisticated. So if you call evaluate and there are no more expressions, you should just return that value. All right, let's turn that into a test. Okay, so test evaluate function with no arguments returns that function. Okay, so expression equals function call, and we're going to give it something more like this. With a lambda expression, and that's the only thing in the list. Okay, patience. All right, and you call evaluate on it. Expr.evaluate with symbol table empty. The result of that, let's say, let's CTEQ. If you do that, you should get expected, and let's define expected. I think we're going to get, well, I don't know if we're going to get the lambda or a closure, but we're going to get one of those two. So I'm going to start with this, and we'll see how that goes. Okay. Well, I'm pretty sure this test will fail. Index out of range. There's apply. Okay, yeah. So it looks like it is a closure, so we'll have to adjust that at some point. But here we just take the expressions. Apply looks like it knows that expression 1 is not interesting. I don't know that you should get the whole expression there. Expression sub 1 dot evaluate. So apply, we get a list of expressions. We create a new symbol table with the name corresponding to the expression, and then we evaluate expression. What's that? It's our held expression? No. Oh, it's our lambda's expression, our held lambda's expression. So a closure holds a symbol table and a lambda, which is somewhat right. And so it's basically taking the symbol table it has as the outer context. It makes a new context with the lambda expression, the name inside the lambda expression, going to this. But I think expressions of 1.evaluate is wrong. So I mean, well, it's not wrong. We're consistent that we pass in all the expressions and then you look at number 1. But I think that's maybe not what we want to do. All right, and then we're blowing up here because there is no 1. We just passed it in. Okay, and it may be because we're applying. Well, somebody turned it into a closure. It wasn't us. Okay. Let's undo this test. And let's make apply. Well, I don't want to pass all the expressions. I mean, if expressions of 1 exists, I want to pass that. Maybe I should pass expressions.rest. Let's try that. Expressions.rest. No, remove first. No, that returns the first. Remove. I don't want the element there. I'm trying to avoid that. What can we do? Expressions dot drop first. Let's go down that path. So I think if I say array of expressions dot drop first, okay, that'll turn the slice back into an array. Parentheses. Okay, so what I'm saying is take out the function from this expressions list. Then when you get in here, you should call 0 because we've already removed the first element, number 0. And the new number 0 is the original first, I think. All right. Let's see if that works. There maybe somebody else had an assumption that there'd be the full list. But it may be okay. We don't do a lot of this. Yeah. Okay. I think that's a little better. All right, but now we're still in this boat. If we put our test back, this test will still fail. Right, because we didn't have an expression 0 in there. All right, but I think what I want to do, let's claim this progress. So for apply, drop the first expression, which is the function being called, and evaluate with the rest of the list. Okay, I think that's what we've done. All right, now I'm trying to demonstrate that we don't consider the case of 0, which is a legitimate case. So if you evaluate with no arguments, then we just return the function. So we've only got one expression going in, the function itself, and we should just return it. All right, so that is here. And this thing should become a loop of some sort in the long run. So this thing should evaluate the lowest level thing with 0 or 1 arguments, and then come back and take the result of that. And if there's more stuff, then evaluate that. I don't know. But clearly the first one should not evaluate if it's just there. Okay, so is it a closure? I think it should be a closure. But I think what we're saying is if expressions.count is 0, then we're going to return function. Otherwise, we're going to call function on the argument it has. All right, let's see how that rolls. Not right yet. Okay, so he called apply. Oh, did I say 0? I meant 1. Because it's still the function call itself is still present. All right. What do we get? Function. evaluate. I think we're going to have to... I mean, this seems like it's a perfectly good... I mean, if it is a function coming back, that's okay. But that name function like that's coming from... I think it's coming from closure, actually. Let's see. We have closure up here. Yeah, so we get back a closure. Okay. Well, his closure.lambda should be the same. Is that enough to convince me? Expected.lambda. Sorry. .lambda is not going to like that. Expected. This as closure. And we want actual.lambda. No, wait a minute. If he is a closure, he should have a lambda. I don't know if it's just not registering. Okay. So we have a closure coming back. And that probably, I mean, that does kind of make sense to me, but I probably could argue myself into the other one too. So I don't know if we can go by that. You get a lambda expression when you evaluate it. Like at some point, it has to capture the variables in its environment. And we do that when we evaluate a lambda and turn it into a closure. And the fact that we get that lambda back, I think is saying we're okay. Let's compare Elm-REPL. Okay, so 3 parentheses, lambda x goes to x. Should be a function, okay. And then what happens over here? Function a to a. Hey, okay. I like it. Okay, it makes me feel good. Let's see. Okay, so we're trying to systematically... Can we have a function... Well, here we've got a function of 0 arguments. That's legit. We just demonstrated it. Okay, now, otherwise, see, I think even a function of 2 arguments, you know, if you remember, we basically turned function of x, y equals x plus y. We're not doing pluses yet, but that's okay. We'll put some comment markers on there. Okay, so if you do that, we compile that, and I believe legitimately, to lambda x goes to lambda y goes to x plus y. And in this, this binds tightly this way, you know, it's right associative. So I think when you call function xy with x, the result is a function of 1 argument with x tied into its own value. And that's why the closure comes in, or we've got the lambda x captured the name and put it in a symbol table. And that's probably good. So if you have an argument, so that tells me I shouldn't even apply it to expressions, because I don't think there's such a thing as a function that takes 2 arguments. It's an illusion for a lambda expression that yields a lambda expression. So a function that takes two arguments is really a one argument function that produces a function. And a one argument function that gets a value, yes, it evaluates it and returns. So I think I almost feel like apply should only get one argument. Okay, at most one to work with, and if you run out, then you're returning the function you got. Okay. All right. So my argument is apply only really instead of this array. Yeah. In most cases, when you think about it, you don't even have to worry about it. You just say, oh, a function of two arguments. Here's two arguments. Call it and it's done. But the mechanism really is a layered function call like this. So, okay. So I think what I'm arguing is this thing could just get expression sub 1, but we need this to be in a loop. Okay. But I think if you don't have a loop, I feel like let's try this experiment. I think that is legit. Like that, I guess. So I'm just pulling out the one argument. What immutable cocoa array? No, I don't think so. Can I do this? Will that let me go? Okay. That, I think, is legit. What it won't do is it won't handle this case of two argument functions. But I think for the one argument functions, we're just giving it one argument. You said if you don't have an argument, just return the function. If you have an argument, apply the function to that argument and return the result. But I think this may work with our current setup. But if you had the part I had in comments and did one of those, I don't think it'll work. How would it? It's never getting that second argument. Okay, so let's try that. We'll try a one layer and then a two layer. Okay, so if I do lambda x goes to x applied to 3, we should get 3. Okay, if I do lambda x goes to lambda y goes to x, well, let's take y. Okay, if I call that like that, that should be legit. All right, now lambda x goes to lambda y goes to y called with 3 should give me a function. Y goes to y. Okay. And if I call that, I don't know what'll happen here. Well, I know it won't work. Actually, I don't know that. It might not work. 3, 4. So a function of two arguments, the first argument gets ignored, the second argument gets returned. Theoretically, we should get a 4 out of this. Okay, and we're just getting the function, and I think that's revealing the gap we have right now. Okay, so if all right, so we got the if, so we apply that function to expression sub 1. I'm going to make apply only take one expression. Okay. Closure apply. I'm going to let it only take an expression. Oh, something's going wrong. Inner context.add name expressions. Yeah, I think I'm okay. Expression. I'll take off the 0 and then I'll fix the name. Okay. This is really the argument. Let's rename this. Let's see if that works any better for us. Okay. You got the outer context. You build up an inner context where the lambda value, the name of the lambda, gets this argument evaluated in its context. And then we evaluate the lambda expression itself. This expression is the lambda expression. Okay. So the call side, you got an expression. I don't know if you need to evaluate that. I think it already is, maybe, but okay, whatever. That's the call argument. That's the substitution of the lambda value. Okay, so if you're trying to evaluate the lambda expression, in our case y, where y was added into the context with its value, then you get it. Okay, let's see. I'm not quite sure this is exactly getting the right context every time, but all right. We turn this into one argument expression. In function call here, okay, it just hasn't caught up. This should be a refactoring. Okay, so we made apply work with only one argument. Okay. Now, all these other expressions, 2 and beyond. All right, so we have a result. All right, let's figure out the test. Okay, function test. Evaluate function with multiple arguments. Okay, and we're going to deal with a lambda expression. Well, let's pull this out. This thing is going to get complicated. Lambda expression x goes to lambda expression y goes to variable y. One more. Okay. So this is x goes to y goes to y. That's our lambda. Now we're going to call lambda with it takes the whole list. So at lambda integer value 3, integer value 4. Okay, x goes to y goes to y. Call that with 3 and 4. Okay, and if you call let actual equal expression dot evaluate an empty symbol table. And I don't know what we're getting back. It should be an expression. I think we should get back 4. Integer actual with integer value 4. Yeah. All right. X goes to Y. Call that with 3 and 4. Evaluate it. And we should get back 4. That seems legit. All right, and let's run that manually and confirm it does not work at this point. Lambda x goes to lambda y goes to y. 3, 4. Okay, it did not work. And let's do it over here. Lambda x goes to lambda y goes to y, called with 3, 4 should be 4. Okay. Got a clear gap to fill. All right, and so I'll just run the one test. Failed. Function is not equal to 4. So in our REPL, we saw it came back with function and it's not equal to 4. And I think the function is we evaluated the first x with 3, we got back a lambda expression, and we just returned it. We didn't try to keep evaluating. So what I think has to happen here, I almost want to write it in down here. So somehow I want to say I feel like that is correct. Okay. Let function equal that. Okay. And then somehow I want to say what do I want to do? All right, now if I do that, what's expressions? Oh, okay. Let's make a I'm working on names later. Let's take expression. We'll make a copy. And then I'll work with my expressions. And same thing here. And I know we can turn this into oh man. All right, I'm probably working too hard here because it's not just falling in. All right. Okay, so I'm going to evaluate the first one. I've got the list of expressions, and Let's make this a var2. Somehow, okay, I evaluate the first one. I get a function. I'm going to drop the list there. And then if while I have arguments, that part seems good. I'm going to do something. What am I going to do? Well, if I don't have arguments, then I'm just going to return function. So that's my equivalent of this. All right, so I come in here. Must be unwrapped. Well, let's assume for now. Okay. Calculate the function. Calculate the rest of the expressions. Okay, if there's none left, then just return the function. That's what we do now. Calculate the function. We don't have to look at the rest of the expressions yet, but if we did, that's fine. We know there is a 0 one because there always is. And if it's 0, we exit out and just return that. If the only one is the original one. And here we've dropped it. Okay, so now we know we get, well, I'll say result equal function dot apply expressions dot first Do I have to bang that? Do I know it exists? Yes, I do, because I just checked that it wasn't empty. Okay. Function was never mutated. Okay, yes. Now, I think well, I think function is confusing me. I think this is really result. And result is here, and result is here. Okay. And then we got to do an update. Cannot assign value of type expression to type closure. But he's not a closure necessarily. That's the tricky part. Okay, if he's not a closure, then he's just a return value and we return him. If he is a closure, we got to go around result.apply. Wait a minute. Cannot assign value of type expression to type closure. Do we need that? Okay. I can feel myself getting buried here. Let's take a break, couple minutes. Hopefully come back and it's clear what to do. All right, so see you in a couple minutes. Okay. Um, I didn't get brilliant over the 2 minutes we're gone. All right, so what I'm trying to do is you grab the expression zero because that's what we come in with. We know that should be a closure. And the list of expressions is the list of arguments. So at line 37, after that, we have the arguments for my expressions. And we're trying to go through and consume all the arguments. But, okay. So we're getting a little balled up in the types here. So only closures have an apply method. Okay, so we probably can't just return here, but if the result is closure, I mean, this is almost like, I mean, that's almost got to be a part of the conditions, right? Well, result is closure and the expression is not empty. So we're only going to be allowed to apply if we're a closure. If we're not a closure, we're just a value and you can return it. Okay. Now my expressions is empty. I feel like there's an error test in there we're going to have to do to make sure both conditions are right. Okay, but here, if the result is not a closure, we're just going to return it. That seems okay-ish. Okay, so I don't think I need to say it here, but I want to say let function equal result as closure, because I know it's a closure now. Or I couldn't have gotten past the while header. And now I can call function. And that seems okay. My expressions never changed. We'll get to that in a moment. Okay. I think here we have to say my expressions equals my expressions dot drop first. Okay. And so I think the two exclamation points here, we know this is a closure, so we can say as. We know it is not empty, so we can say first. And now it may become empty. All right. I think this is closing in anyway. The gap here is if I exit out of closure, let's say I exit out, we're not a closure. So I've evaluated things and all I got back was 3. So this is the 3-4 case again. I should be complaining here that something went wrong. Sorry. I should be complaining here. If you're not a closure, then you should not have any arguments left because only closures can evaluate. So we need a test for that. When result is not closure and my expers is not empty. Should be an error. All right, what about the other way around? If we're a closure, okay, if we're not a closure and this is empty, we're good. If it's not empty, we got a problem. If we're not a closure, if we are a closure, and the expressions is empty, then we're just returning the closure, and that seems okay. If our closure and expressions is not empty, well, then we keep trying to evaluate. Okay. When it takes you 10 minutes to do it, it's not as encouraging even if your one little test passes. Okay, well, here's my failing 3 tests. Okay. Evaluate a function call Internal errors should not happen. I really would like to know where that's from. I feel like that's expression or something. It's a cannot happen. Okay. All right. So lambda n goes to n called with 42. Our scheme does not work. So function call lambda n goes to n. So expression dot evaluate context somehow should be the same as expression dot evaluate context. Gets me back a closure. My expressions is empty is false, so I would like to say the first one was a closure. Now we apply expressions dot first with context. Seems like it's okay. This one got an error message. Non-function. Oh, it got 2. Okay. That's the case I was talking about. Yeah, so we don't check this case. All right. Well, that tells us to put this to do this. Let's fill in. Let's fix the one case. Okay. If result is not closure. Okay, if our result is not a closure and my expressions are not empty, then I got to return this. If it's not a closure and I still have stuff left, then I got an error. Okay, so that's that to do. Let's see if we get down to 2 errors. Okay, we did. Now this one came back with internal errors should not happen. And I think, do we see the same thing here? Okay, let's see where that comes from. Whoops. Cannot happen. Okay. Well, it's got to be in one of these. Expression. Well, if we call the default evaluate, let's break there. Okay, so somehow we're calling expressions evaluate, which we never did before. All right, but let's pick one of these tests and give it a run. We'll take this one was the simpler one, I think. Okay, function call tests evaluate. Variable evaluate. Let's see what our test was. We have lambda n goes to n, evaluated with 42. Okay, and we evaluate the function call and expect the integer. Okay, so let's Let's get in our function call. Okay. And we'll stop here too. So expression sub 0 dot evaluate should be a closure coming back, and expression should have 42 left in it. My expressions. Result is a closure. We expect a yes, not empty, yes. Compute the function, apply it. Okay. Run the same test. Okay, so let's look at result. Symbol table and a lambda. Okay, that's a good sign. He is a closure. And we can see the n. And this expression is variable n. Okay. So we have a closure here. We have my expressions. Are you going to give me anything? Well, he doesn't like that. My expressions drop first. Okay. Can I count? 1. Okay. Step over. We expect to go into the method. Okay, function result is closure. Function is the closure. Now we want to apply expressions.first. Let's step in. Expressions.first we expect to be integer 42. And we expect to go into the closure apply. Okay. The argument. Oh. Is a lambda expression. That doesn't seem right. Did I say expressions.first and not my expressions.first? Sure enough. Okay. All right, we'll see how lucky we are. Okay. Oh, golly. All right, clean it up and then see if we believe it. Yeah. I think we've done the right thing there. Okay. Now, I'm trying to figure out where we could catch something going wrong, because things can go wrong. All right, so we get the function, we evaluate it. That gives us the lambda expression, puts it in a closure, and we come back with the first argument here. If it had no arguments, it should just return the result. Okay, now we know we have a closure. We know we have an argument. And we return. We apply the closure with this as the argument, integer value 42. Get the result and then skip to the next argument. Okay, so result, and then we decide if we're still parsing closures. All right, so now let's run. My hope is our 2-argument lambda works now. Lambda x goes to lambda y goes to y applied to 3 and 4. Okay. Good. So, what can we make funny? I don't know. I feel like I've got to get at least one argument in to make something happen. I don't know. I want hmm. So if I define, let's try defining this. So function equals should be okay. Lambda x goes to lambda y goes to y. So this is a second argument function. Okay. Takes two arguments, returns the second. Function of 3, 4. Evaluate. Yes. Function of true, false is false. Okay. That seems good. Now let's muck around. Let's say there's m equals 3. Now I'm trying to break the variable stuff. So let's make g be a function. Lambda x goes to m. What would that do? And I'm not quite sure when and where m gets evaluated, but somehow what we want, m is 3, so if I call g of 2, I should get 3. That's good. Okay. So the reference here, this m, they call that a free variable because it's not part of any enclosing lambda. And so we have to go out to the environment to get it. And the reason we did the closure thing was that it captured the current environment, which has a definition for function and m. And when you reference this thing, we call g with 2, it plugs in the 2, evaluates the 2, plugs it in for the x. There's no x's, so there's nothing to substitute, and it asks for m, and it should get m from the outer environment, not the lambda, but the enclosing environment. That's good. All right. I mean, I'm not sure we've totally got it straight because I'm not sure when the contexts go, but we have this let. Elm has a let. Let's see if we can. Maybe I can get that summary right up on top, right? Yeah. Let expressions. Okay, so here, I think we want to find a way to define this as being like a lambda, I think. So I think what we're trying to say is lambda 24 goes to, lambda 16 goes to this expression with 24 being given the argument 3 times 8 and 16 being given the argument 4 times 2, 4 to the 2. That's, yeah, I mean, that introduces names, but it doesn't really get at this problem we're talking about. It's like, where do you find names, that you might have to worry about levels and outsides and stuff? I don't know. Okay, but I think we've done something really good here. I mean, I'm not sure we got all the details right, but evaluating functions with their arguments and all that stuff, that feels like a really good place to be. So we made function evaluation attempt to keep evaluating until all arguments are exhausted. Okay. Now let's try another one. So let's see if this currying thing works. That would be good to know. So if we take function right now as x goes to y, and if we say what is function of 3, it should be a function, a one argument function. Yeah. So if we say function of 3 applied to 4, we should get 4. Oh. Well, is my syntax okay? What if we just do function of 3? Missing a right parenthesis in line 1, column 5. 1, 2, 3, 4, 5. Okay, well, that gives us something to work on, doesn't it? Function of 3. Let's replicate that. Where do we do? Function lambda x lambda y goes to y. Lambda x goes to y. Okay. And if we say function of 3 should be a function, function of 3 in parentheses should be a function. Okay. Whereas we say we should have had a parenthesis in column 5. Well, 1 is the paren, 2, 3, 4, 5. Expecting it where the 3 was. Oh, I bet our parentheses expressions don't do multiple expressions. Yeah. Parser. Expression goes to these things. Yeah, this should really be expressions. Let's... Or expressions. Where's left then? Okay, so parenthesized expression. Goes to expression, comma expression. If token is comma, oh goodness. This overloading of syntax, it just is truly annoying. So we have to look for expression, comma, expression, but this could really be expression, 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 because this could be parenthesis function of 3, 4, comma, function of 3, 4. Expression there. I feel like that should be calling expressions. If there's no comma, you should be able to say 3, 4 and be fine. Okay, so let's try this. 3, 4. All right, now we got function of 3. Let's try function of 3, 4 with 2. Yeah, because function of 3, 4 is 4. So the syntax is really lists of expressions between commas. So let's make sure that works. Expressions.append. Well, let's look at our expressions. It returns that list. And then the caller has to know I mean, the caller is basically the one wrapping that function call in. Okay. All right, so we're going to call a multiple argument expression and then see it go nuts. This is a parsing test. Why is my computer like pegged out? Oh, no. Okay. 17 meg is nothing on this thing, I hope. Parser tests. Okay. So parenthesized expression. Let's say a parenthesized expression may contain multiple. How about may contain function calls? May contain function call. All right. So we want to make this a successful parse of lambda x goes to x with 3. Okay, so I got this outer parenthesized expression contains an inner one and an extra backslash. Is that what we really expect? No, we expect a function call. With a lambda expression x and a variable x goes to x and integer value 3. Okay, that's the lambda parend. Okay. And I guess this will fail. All right, what did you get? Missing a right parentheses. Line 1, column 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's kind of where it was reporting it before. Okay. Let's see. We got a very brief time left. So, expressions. So my claim is this should really be expressions, comma, expressions. Like that. And if you call expressions, you know, this is going to fail. It doesn't feel like a 5-minute solution. So I think I'm going to stop here for the day. I don't often do this. Usually I try and run over 5 minutes. But, you know, changing this to expressions is going to make it return an array of expressions. And then we got to deal with it, basically. And var expressions equals bracket expression. Okay, this is the result, the var expressions. And maybe wrapped up in a tuple. Yeah. I'm going to do one of these. I don't tend to refactor too much when I'm red bar, but I think we'll set ourselves up a little bit here. Resulted expression is an array expression because you could accumulate multiple whatevers. And I almost think like here we need to, I don't know, we'll have to see. But anyway, I think this will be a good place to pick up. So we've got functions working at the top level. We don't have functions working inside parenthesized expressions because our parenthesized expressions assume you're trying to create a tuple out of simple values and they don't know how to deal with function calls. So we're addressing that in our thing here. We may find that we really want expressions to come back as something else. I don't know. Maybe there's another layer in there where it could do the wrapping and figure out the error expressions and stuff like that. But we'll pick up there next time. And I think with that, I mean, I feel like we're kind of through this tricky part of expressions and function calls. Assuming our solution holds up, well, yeah, I mean, I'm still worried about the naming stuff, but assuming our solution holds up, then I think we could maybe move on to operators, and then we can get some. We'll have to improve our expression handling even more, and it'll let us write a little bit more sophisticated routines. I think that'll be a good thing. So let's pick up there next time, which is, let's see, today's Thursday, so Tuesday, 1 to 3 p.m. again, and we'll get there. But I feel like yesterday and today, there's some stumbling around, but I think we are, I mean, this is a functional language and we just got functions working. So that's a good thing. And maybe I should have tried to get like lambda expressions and integers and just done nothing else until I got those straightened out. Might have been a better way to start this interpreter. I mean, like, do you really need int and float, stuff like that? So we'll pick up there next time, 1 to 3 p.m. Eastern Daylight Time. And thanks for joining me today, and catch you in the future. Bye-bye.